Its power, unprecedented. A deadly combination of extreme wind, water, and surge.
During the height of Superstorm Sandy, the water was some 3 times my height where we're standing now. That was unthinkable for some residents, but not for some local scientists.
In 2011, more than a year before Sandy rocked the East Coast, Hurricane Irene barely missed New York City, giving a wake-up call to the scientists on this quiet campus of the College of Staten Island.
Following Irene, I pulled together this interdisciplinary team from the High Performance Computing Center, the field geologists that had experience from the area, to say, can't we start doing some computer modeling to see what might happen if we were to have a 12-foot surge.
I was always concerned about hurricanes for Staten Island because we have a right angle in the coastline. And if a hurricane came perpendicular to the coast in New Jersey, it would put us in harm's way over here. We're in a very low-lying area, so the storm surge can come right up here. Now, when it was a former marsh and wetlands, there was no problem. When you put houses in there, it becomes a real problem.
Dr. Bedemoff discovered a map from 1902 of Staten Island that showed the original wetlands. From that starting point, he mapped a century-long building boom. The next step? Use the college's $4.5 million high-performance computers to track what would happen if the island took a direct hit.
With that data that represents where the water can and can't flow, then there's a superposition of weather data that is incorporated into our model to represent the winds and the pressure profiles that drive the storm surges.
The model, called AdCirc, can forecast surge with street-level accuracy. In fact, it proved itself when Irene hit the North Carolina coast in 2011.
It was within a foot or a half of a foot in almost every region that we had data for in North Carolina.
The new AdCirc model comes with a hefty price tag, $100 million. But its ability to measure the tides, waves, and river flow, along with the potential storm surge, is seen by many as the next step in protecting the nation's coastline.
The New York shoreline is very, very complicated with all of the harbors and shipping channels and titles, and being able to use the computers to really accurately predict exactly what's going to happen almost on a block-by-block basis is very, very important.
Information that becomes even more critical as those who live here consider where to rebuild from Sandy and protect themselves from the next storm on the horizon.
I'm meteorologist Stephanie Abrams.